Sir, naka-mute po kaya?
Okay. So, welcome back again. Let's continue. So we have a floor joist 50 by 200 millimeter in height. So this one is 200. So obviously a floor joist made of wood. This is simply supported joist, just like a beam, 4 meter in span. So it looks like this. So this is your floor joist. If it's simply supported, usually it is being supported by a beam. Okay. Floor joist by which after that one, the floor joist carries the plank, or some uses plyboard 1 inch in thick. So we have here the load, uniform load. This has to carry a floor loaded 5 kilonewton square meter. So 5 kilopascal. Compute the center line spacing. So what would be the S between this joist? To develop a bending stress of 8 megapascal. So meaning the maximum bending stress, the maximum of B is just limited to 8. Okay, megapascal. Okay. What safe floor load should be carried on a certain line spacing? That is the second question. So as you all know, if you have here, these are the beam, the floor joist, I should say, floor joist being transferred to this beam, and then the beam will be carried afterwards by the column. So if you have here this floor joist, the tributary area, or the area being carried by that joist, is this one, okay, as shaded. This is just actually 1/2 of S here, and then 1/2 also here that follows. This is just also the same as S. So for the question to compute what would be the S, it is just simply you have here 5 kilonewton met 5 kilopascal as your load. Okay. Floor load, or 5 kilonewton square meter. If you are going to multiply 5 kilonewton, so W, what would be the W? If you are going to multiply 5 kilonewton meter squared multiplied by the spacing, it will give you what? 5S. The unit now is kilonewton meter. Okay. So this follows that this one is 5S, kilonewton meter. If we get the moment, okay, if we get the moment, give us the maximum FB, then we can compute S. Okay, so we have like this one. Maximum moment for simply supported beam is WL squared over 8. W is 5S. Okay, 5S. L is 4 meter squared. And then 8, you have 10. 5S. Okay. 4 times 4, 16. Divide 8 is 2 times 5 is 10. So 10S, that becomes kilonewton meter. If we substitute F is equal to 8, this one, the maximum bending. Moment is 10S, kilonewton meter. We multiply by 1 times 10 to the power of 6 to become Newton millimeter. B, you have here 50. D is 200. All in millimeter, okay? All in millimeter. Millimeter, okay? This is millimeter cube. Makancel yung isa, squared, okay? So our consideration of here of is which S, okay? Ang consideration natin ng S here is in terms of meter, kasi nga pag minultiply natin dito, yung 5 kilopascal, to 5 kilopascal, minultiply natin ng S, naging kilonewton meter. In other words, our assumption for S is in meter. So obviously the answer 0.267 kasi nagka-cancel out dito lahat ng mga unit. In other words, S is obviously or should be implied to be in meter. That is 0.267 meter. In the actual, mayroon naman gawing 0.267. So ginagawa niya 0.25. Hindi 0.3 kasi hindi na siya safe. So next is to compute what would be the safe floor load if the spacing is 0.4. Actually, it's just similar to the first question. First question ang kino-compute S. Itong second question ang kino-compute naman is safe floor load. Okay? So, S is 0.4. Instead of S, W naman dito. Okay? So, W, ina-assume naman natin dito na kilonewton square meter. Kasi nga, nung minultiply ng 0.4, naging kilonewton meter. So, the same approach, we just go back to this formula. Then this one is kilonewton meter. We multiply 1,000 Newton millimeter, and then millimeter squared. We can compute F is equal to 3.33. Okay. So how about this one? This is what I'm saying earlier. You know, now how are you going to determine your C from the formula, from the general formula that is called MC over I. Okay. C, in this case, kung kukompute natin yung maximum value, it should be 160. Okay. Bakit YT? Okay. If you have a beam, ito yung beam, ito yung support. Pagka mag-deflect siya, sa taas compression, sa baba tension. So ito dapat compression to, ito dapat tension. Yan, nagkamali lang sa pag-type. Okay, so this is an inverted T-section of a 4 meter simply supported beam. So yung okay. Ito yung beam mo. 4 meter. Okay, simply supported beam. Pero ito yung section. The beam carries a uniformly distributed load na W. Okay? Distributed to the entire length. Now we determine W. Determine the W, this W. If FT is 30, FC is 70. What does it mean? The allowable flexural stress at tension side. Ito yung tension side, okay? If this is our neutral axis, ito yung area sa baba ang tension. Ito naman sa taas ang compression. Okay? So, let us compute first the maximum moment. WL squared over 8. W, ito yung tinatanong. Okay? 4 meter span, so you have maximum moment as 2W. If we're going to consider the tension side, okay, according to the given problem, the tension side, the maximum is 30 megapascal. You substitute 30 megapascal, okay? Okay. So, you have here 2W, okay? 2W. YT is 80. Okay, ito. 80. Bakit 1,000? Nag-convert lang tayo dito ng ito para maging parehas siya. Okay, wait. Yung 2W, anong consideration natin ng 2W dito? Newton meter. Kung Newton millimeter itong W, dapat ma-convert mo, multiply ka ng 1,000 para maging millimeter. Kasi ito, Newton millimeter squared. Okay. Anyway, pag hindi mo yan may lagay na 1,000, magbabari dito yung mga decimal places. But the numerical value still would be the same. But we have to consider what would be our consideration for W. Okay. And in the board exam, this one is for the concept. In the board exam, very specific naman yung mga assumption ng units. Okay. So what you just need to understand here, how are you going to use 80? How are you going to use 160? Okay. So here YT, because we are using the tensile stress, FT. So we use 80. And if you're going to use the compression side at the top, you're going also here to use 160. Okay. At the compression side. Thus, we can also come up with this one. Okay. Anong pinaka-safe niya? Ang pinaka-safe dito na W is yung maliit. For what reason? If we are going to use this small one, okay, pag gamitin natin itong small one dito, okay, for example, we are going to use this one here for compression side, and this one is compression, this one is tension. Okay. If we're going to use this at the compression side, for sure, W will be smaller than 70. And if it's smaller than 70, it is safe. Okay? Dapat hindi siya mag-exceed sa allowable stresses. Ang allowable bending stress at the compression section is 70. Allowable bending stress at the tension section is 30. But if we're going to use 3759 here, ito, di ba? Itong value, 30 for sure ang nasagot natin. But if you are going to use 4375 as our safe load, you solve the stress in the tension side. For sure ito, pag itong ginamit natin dito, for sure, it will be greater than, okay, the value here would be greater than 30. And it is not safe anymore kasi ang limit value ng tension dito is 30. Ang limit ng flexural stress at the compression side is 70. Okay? I hope everything is clear with you. We'll move to the next slide if there's no question. Okay lang ba? Pa-thumbs up if it's clear. No more question. Okay, thank you. Okay. And we also have the shear stress, okay, that we have to review. Ito naman ang general formula ng shear stress. VQIB. Ano yung V? Ito yung maximum shear. Ano yung maximum shear? Kung halimbawa, mayroon kang beam dito, okay, this is the beam, this is the load. Usually for a simply supported beam, ang maximum shear is the reaction. R1, R2. Kasi nga, pag mag-draw tayo ng shear diagram ito, the shear diagram is just this one, okay? Ito yung maximum na value. So, between the two, halimbawa, nagva-vary siya, hindi siya uniform load. Between the two reactions, yung malaki, yun yung maximum shear. Pero pag the case is it's a uniformly distributed load, R1 will be equal to R2. In other words, V is just equal to R1 or R2. Q, first moment of area. Don't you know that I is the second moment of area? Di ba? Kasi nga, yung sa, if you are going to recall, ng moment of inertia, the formula, okay, is just equal to y squared, halimbawa, dA. Okay? dA. Ito actually parang moment ito. Moment. Second moment. Nasa power 2 siya. Ang first moment of area kasi A, pag minultiply mo siya ng y, which is y is the distance, nagiging moment. Pero moment of area. Okay? Ito, dalawa ang distance na kino-consider sa moment of inertia. Okay? First moment of area, it's the Q. Okay? It's just equal to A times Y. Now, if it's a rectangular section, we do the same in the derivation for flexural stress. Itong will come out with this formula. For some, we could represent this as 2A. Okay? 3V, BD is the area. Shear flow, okay? VQ, walang I over B lang. Okay? So that becomes shear flow. So let's have an example. You have here a simply supported beam, 4 meter long, has a cross section. So ganito lang, ano? This is a simply supported beam. Has a cross section, hollow, butas yung gitna. Determine the distributed load. What is W? Okay. This is 4 meter. Which can be applied over the entire length of the beam if the shear is limited to 1.2 megapascal. Okay, dapat less than or equal to 1.2. We do this, we say equal to 1.2 megapascal. Dapat di siya mag-exceed para maging safe. Okay? Okay. So, first, we calculate, of course, the reaction. Pag mga simply supported, madali lang pag-compute ng reaction kasi it's just W times 4. Ano to? Ang resultant load. Okay? Resultant load is W times 4. It's just equal to RA plus RB. In other words, RA is just W4 over 2 kasi equal naman yung RA at saka RB. We need this one because this is our 2W Newton. This is our V. Okay, ito, maximum shear. Q, which compute later. I, you can also compute. B, anong tinatanong is just W. Okay? So, if you have this one, How are you going to compute I? Ito naman pinakita ko. Alam ba, cut ko ito dito. Ito pinakita ko na dito. This is 25 kasi nga, ito bawas natin ito mamaya. Okay. This is also 25 because this is 50. Okay? First, we compute the area. Okay? Area of the bigger section. Itong big section, ano, ito, which is just, if this is 200, okay, ito is 100. Ito naman yan, no? Okay. The big one is just equal to 100 times 100, okay? From the formula that Q is equal to AY, okay? AY, Y is the distance from the neutral axis. So itong neutral axis, itong neutral axis, ito yung malaking rectangle na sinasabi ko, na 100 by 100. Ito yung magiging, okay, Y, which is just 1/2 of 100 na 50. Kaya ito yan, okay? How about this small one? Ito naman na shaded. Okay, itong shaded, ito naman, no? Ano itong distance? Okay? Kasi nga, this is 100, ito. This is 200, this is 100. In other words, this one is 25, this is 25. Ano, no? 100, 100. Okay, this is 25, 25. Ano, 50. This is also 50. Okay? This is 50. This is also 50. Para maging 200 lahat. 100 plus 50 plus 50 is 200. Okay, so this is 50. If this is 50, kasi 100 ito, this shaded area, the height is also 50. So, this is all 50 by 50. 50 by 50 times, yung y dito is from here. Ito, 25 ito. Kasi nga half lang ng 50. So, we can compute Q. Now, the moment of inertia, as simple as the moment of inertia of the big rectangle and then the small rectangle. The big rectangle is BD cube over 12, di ba? BD cube over 12. Ano yung B? Ito, 100. Ano yung D? Okay, and D, ito malaki pala ito. Okay? And D is 200. Cube over 12. Yung small naman, itong sa gitna, ayun. Okay? Malino naman eh. 50 by 100. Okay, ito yan. BD cube. B is 50. D is 100. Cube over 12. Calculating further, then we can compute this I. Substituting to the formula, FV. Okay, ito. Newton millimeter squared. V. Ito, 2W. Naka-Newton na siya. Okay. Q. Ito, millimeter to the power of 3. I. Ito, millimeter to the power of 4. Okay. Then, B is in millimeter. So, therefore, we can compute W. Okay? Is it clear? I think it's clear. Okay. We'll move to moving loads. Okay? Moving loads tayo. If you have any question, tanong muna. Kung wala, we'll proceed to the moving loads. Okay? Okay, good. Okay. Welcome, Joy. You can just follow back. Nasa video naman i-share ko mamaya. Okay? Pero maganda din na nag-attend kasi makakapagtanong kung may kwan. Anyway, kahit kung nalilate kayo, may tanong kayo sa mga previous na kwan, you can drop the question in the Teams, in the classroom, or kahit sa WhatsApp, pwede kayo mag-drop ng question. Okay, let's continue. So, I'm going to present to you the moving loads, most likely for 2 well and then the 3 well. So, ito lang naman dalawang mga kwan lumalabas sa board exam. Okay? It's either yung 2 kilong at so yung 3. Lagi itong lumalabas. Okay? So, the rule is, how are you going to get the maximum shear? You just have to place the biggest load on the support reaction. Amba ito, Kung biggest load ng P2, i-move mo to, ilagay mo dito. Okay? Then you get the maximum reaction. Of course, ang maximum reaction yan, kung nasaan yung load. Ano? Kung dito, obviously, dito yung maximum reaction. Kung R2 ito R1. Okay? The maximum moment place the center of the resultant and the biggest load on the center of the span. Okay, I'll show you this one. Okay? So, kung meron ka dito first for shear, okay. How are you going to compute for maximum shear? Halimbawa, okay. Halimbawa, ito yung, wait. Okay. If this is your beam, you have a beam or a bridge, usually mga moving loads, a bridge, okay, R2. So, for you to compute the maximum shear, you just have to place the bigger load. I'll write here B for the bigger load, and then you have here small load, okay? You have a certain distance A. Then, if it is 1.2, R2 is the maximum shear. Okay? So, magtitik moment ka dito sa 1, then you can compute R2. Okay? Now, how about maximum moment? Maximum moment. Of course, yung tawag nito ito, makakompute mo nito yung resultant nito, no? Kung bigger load ito, ang resultant nito, somewhere here, mas malapit sa bigger load, ano? Andito yung X. Okay? Ang sinasabi sa rule sa moving load and computing for the maximum moment, you have to identify where's the center of the beam, R1 and then R2. The center line is here, okay? For example, this is center line. This is X over 2, L over 2, and this is also L over 2. Okay? Okay. So, what you need to do is to place, if this is the, okay, this is the bigger load, okay, place the center between R and B coinciding with the center line of the beam. So, kung ito yung, okay, if this is the bigger load, andito supposedly yung resultant load. Andito naman yung small, what's this? Small well load. Okay? If this distance is all equal to A, ito is equal to X. R is equal to S plus B. Okay? Maximum moment is just located here. If I'm going to cut this section and consider this side, okay, I can take this moment. Ito yung M na yun, okay? M here is just equal to, ano yung distance? Makakompute mo naman tong distance eh. Okay? Makakompute mo tong distance. Sabihin natin yung distance na to is distance P. Okay? Distance P. So moment here is just equal to R2 times P. Okay? How are you going to compute X? Take moment. Ito yung S. Ito yung B. Ito yung R. Ito yung X. Ito yung distance na A. So, magtitik moment ka lang dito sa B. Okay? So, R times X is just equal to S times A. Makakompute natin yung X. Okay? Alam naman natin na R is just equal to S plus B. Okay? So, let's have an example. Malinaw ba? I think it's clear, no? Okay. Here's the question. A truck with an axle loads 60 and 40. Of course, the resultant is 100. 60 plus 40 is 100. On a well base of 5 meters, 5-meter rolls across a 10-meter span of a bridge. Sa bridge siguro to, okay? Which of the following gives the maximum bending moment of the beam? Which of the following give or compute the maximum shearing force or the maximum shear? And then compute or identify the location of the 40 kilonewton load from the left support. Okay, from the left support when maximum moment occurs. So during the maximum moment computation or the location of your 40 kilonewton, you just have to identify its distance from the left support. So for example, you have this one. Okay, you have this well load. This is 60, this is 40. This is the center line. You just have to place. Okay, you just have to place the center line between. Okay. So how are you going to do that? This one should be, have to identify this. Okay. This one should be, okay, x over 2. Okay, this one should be x over 2. This is also x over 2. In the calculation here, you can say, what is x? Hindi ko pinakita dito. Okay, let's compute. What is x? Okay. R, which is 100. 100 times x. Dito natin pinapaikot, okay? Dito na part. 100 times x is equal to 40 times 5. Okay? 4 times 5 is 20. That becomes 200 divided 100. X is equal to 2 meters. So dapat ito is 1 meter. Ito rin is 1 meter. Okay? If this is 1, it follows that this distance is, ano to? 3. Okay? 1, 1 plus 3. Okay? It's 5. And if this is 5 meter, this is 1, 3. Meron pa dito natitira na 1. This is remaining 1. So 1, 3, and 1 to the center line. That becomes 5. If this is 1, yung natitira din dito is 4. Okay? According to the rule, ang sabi ng rule, you just have to take the moment, okay, where the location of the maximum load. So ang sinasabi, ilagay nyo lang yung center between ng reaction na ng resultant na 100 saka 60, yung center niyan, ilagay nyo sa center din ng beam. Okay? So this is the center of the beam at 5 meters here. This is 1, this is 1. Okay, so we identified already this dimension. So we just take moment here, consider here. Okay? So ito na yan, no? R1 is equal to 40. Asan ba yung R1 yan? Ito yung R1, ano? Nag-take moment ka dito, R1, okay, times 10. Ang ginamit niya dito is 100 times. Mula dito hanggang dito, ang distance is 4. Okay, R1 times 10, and then 100 times 4. Ito 100 times 4. Pwede din ang gamitin yung 60. 60 times 6 plus 40 times 1. Pero madami kayong load na compute 10. Whereas if you're going to use this resultant, ito lang, you can have 40. And then considering this side at the left support, ito yung arrow natin. The moment here, so ito lang makikita natin. Ito yung wheel load na malaki na 60. Ito lang ang kukumpute natin na moment. Okay? What is this moment? This is R1 na equal to, ano yung R1? Equal to 40. Ito yung big load. Okay? B. So, what is moment? Okay? Ito yan. It's just R1 times 4. 40 times ano itong distance? 4. 4 meters. Becomes 160 kilonewton meter. That's the maximum moment. Now, maximum shear. Ilagay lang yung itong big load dito sa support. Pag ito ilagay mo na 40, ilagay mo dito, 40. For sure, yung value ng shear mo is not maximum. Should have to place the biggest load to the support. So, from here, you can compute R2. Okay, this is the calculation. Ito na nga, mag-take moment ka dito sa R2. 60 times 10, 40 times 5, you get R2 is equal to 80. Pero meron din isa, di ba, meron tayo dito resultant na 100, Ang distance dito is 2. Pwede din itong gamitin nyo. Ang distance mula dito, if this one is 10, okay, 10 meters, this is the maximum na 100 kilonewton. Kung 2 ito, 8 meters, we can also compute here R2. Okay. Ang maximum dito dapat R1. Let's see. Okay. Ang maximum shear talaga dapat dito sa malaking kuwan. Okay. Okay. Mag-take moment ka dito. Habang mag-take moment tayo, di ba mas mabigat naman talaga i-carry sa under ng load. Okay. I will see para makita natin. Take moment ka dito sa 2. Compute natin yung R1. At tama nga, hindi to 2. R1 ito. Okay, kay 60 times 10. And then, nagkamali lang. It's R1, okay? 60 times 10 and then 40 times 2. So, we'll see here. Take moment here. Pero ang maganda nito na I'm going to present is just you only need to use 100 kilonewton. So, you have here R1 times 10. Okay? And then you have, dito ka nag-take moment. Okay? Take note, you take moment here at 2. And then you have here 100 times 8. Cancel yung isang 0, cancel yung isang 0, R1 is equal to 80. Okay, parehas yung answer pero mas madali itong pinakita ko. Okay? Next. Distance of the 40 kilonewton from the left support when the moment is maximum. Ito yung maximum moment na present ko kanina. So, ang distance, okay, from the left support of the 40 kilonewton load, kasi na-present ko na nga kanina na 1 meter yung distance na to. If this is, the total is 10. If this is 10, obviously from here, going here, is equal to 9. Okay? Board exam type 2. Ano? So, ganito lang yung mga question naman. Okay, any question? Any further question? Okay lang? Okay, very good. So, activity, I want you to try this one. Okay? Go to our classroom. In our classroom, there is this week 6 activity 2. Wait, ha? I want you to answer this week 6, okay? Activity 2. Ito na. This one, week 6, activity 2. So just hint, i-try nyo muna yung, okay, itong tatlong, ano, you try this 3 wheels to compute for R. Okay? Compute nyo R. Kung saan ang distance. Ito naman 3 meters at 5 meters. And then, place, okay? You place the, if you can compute now what is this X, ilagay nyo na yung the location, ilagay nyo yung R and 30, between R and 30, you place it in the center line of the beam. Pagka malaglag yung isa, okay, if for example, the 10 kilonewton meter is no longer in the beam, so disregard nyo yung 10 kilonewton meter. Dalawa na lang i-consider nyo. That is if 10 kilonewton is not, could not be found in the beam. So the distance of the beam is 12 meters. Okay? You're going to compute first the distance of the resultant from the 10 kilonewton. So compute nyo yung, kung itong gamitin nyo na X, kung itong compute nyo na X, okay, that would be the question number 1. Okay? And then, compute the maximum moment. Pero kung itong gamit nyo na X is, it is just 8 minus X will give you the distance from the 10 meter load, 10 kilonewton load. So yung question, compute the maximum moment of the beam, you're going to place the center of R and 30 in the center of the beam, coinciding the center of the beam. And then compute the maximum shear, just place the maximum load and the support. Then you get the reaction. Okay, I give you 10 minutes, 10 minutes for this one. Just go to our classroom, this. I'll give you 10 minutes for this. Okay. Let's continue. So I've seen your answers in the Google Forms. So let us discuss. Okay, so you have here just 3 well loads. The first question is to compute what will be the distance from 10. So it is just that the R, or the total load, is just 10 plus 20 plus 30 is 60. It is just 60 times X. Let's say this one is X. We use here as X, okay? And then you have this 10 times 8. You have here the total is 8. And then 20, for 20, you only have 5. Okay. And then for 30, actually it doesn't need to be written because you're taking moment here from 0. So meaning X is 3 meters. So the remaining here is 5. Okay. 5 meters. This is 8. The remaining is 5. So that's for question number 1. For question number 2, what will be the maximum moment of the beam? So when we write, when we place, okay, this is 30, this is 3 meters, okay, 3 meters. So this follows that this is 2, 3, okay, this is 2, 1.5, 3, this is already 3.5. So here, the remaining is, if this is 3.5, only 2.5, okay? Since the distance of the 10 kilonewton wheel load from the 20 kilonewton load is 3 meters, ibig sabihin, wala na siya sa beam. So we are going to analyze again the beam, considering only these two loads, this 20 and 30. Okay? So from 20 and 30, from 20 and 30, okay, this is 20. Since ito na lang consider natin, okay, 30 and then 20. So we will compute again where's the location of our R. Sorry. R, yung resultant load. Okay. R is equal to 50. Okay. Not 60. 30 and 20 for this specific load is only 50. Okay. We compute here X. What is X? And then this distance is equal to 5. Okay. Thus, we have here 50 times X, okay, or Rx, and then you have 20 times 5. 5 times 2 is 10. Okay. Tama? Sorry. So X is equal to 2. Okay, 50 times X is equal to 2. So, ilalagay na natin yung R. Ito 50, okay? It's not 60. 50. Okay. The center line of 50 and then biggest load. The same na yung approach natin sa first problem na two well loads lang. Ito yung x1, ito x over 2, and then x over 2 here also. This 1 and 1, make it 2. Okay, so between 20 and 30 is 5. So in other words, you have 3 here. This is 1, 3. And this one is 2 to make this one as 6. Now to compute for the maximum moment, ito lang kailangan natin. Okay? We need to compute for R1. Ito na. Okay. What is R1? Consider 50. We can consider this 50 times 5. Okay, then R1 times 12. We can have R1. Once we compute R1, multiply it by 5 kasi ito yung ito na consider natin dito. Ganun na lang. Ito yung R1. Ito yung biggest load eh. Okay? Ito na yung kukumpute natin dito na moment. Kaya you have this one. R1 is 20.83 times 5. We can compute 104.15 as our maximum moment. How about the maximum shear? We'll go back again with the 3 loads and then place this maximum load and the support. So we have here 60. Compute natin distance na 3 from here. So we take moment here. Okay. So R1 times 12, total distance. Total distance is 12. R1 times 12 and then 60 times 9. We can compute R1 is equal to 45. If this is 45, R2 is simply equal to 15. Kasi 15 plus 45 will give us 60. Yun na yung total load of the wheels. Okay? Any question? Any question? Still have enough time. We'll start with the let's start with the next topic. Maybe only have 10 to 15 minutes. Okay, so we'll continue. From moving loads, we have deflection methods. So I'm going to introduce to you 2 methods, the double integration and then area moment method. Okay, so in the double integration method, what you need to double integration method, what you need to remember is the double integration approach and the calculus, integral calculus. Okay, so how are you going to do that? Okay, I better do it like this. So if you have your beam, okay, you have here a beam. How you apply the double integration method? The moment, okay, or we call here okay, the double prime, or should we say what's this? The double integration or the double prime, we call this y prime double prime. We integrate it twice is equal to your moment. Okay, and if you're going to integrate this one is equal to your slope. Okay. Now, I'd like to stress out this part. If you remember if you can still remember in differential calculus, you have maxima and minima. You can get the maximum and minimum value of a certain whatever length or the width when you get the first when you get when you differentiate, okay, or when you get the derivative, okay, when you get the derivative, you get the maximum value. It's either if you have the curve, when the value is maximum, okay, the slope here is 0. So there's the relationship of the derivative value, or when you differentiate, to the slope. When you differentiate, or when you get the derivative of a certain equation, okay, when you get the derivative equation, you get the maximum value when you set, okay, when you set the slope equals to 0. So when this slope is equal to 0, meaning straight line siya na ganito, ganito. This one is at the peak or at the maximum point. Okay, at the maximum point. So that's why, okay, the first derivative is, when you get the first derivative, you get the slope. And when you integrate again this one, you get the deflection. Okay, you get the deflection. So obviously we are trying to calculate here in the double integration method the deflection. Okay, it's all about deflection method. Well, we are going to compute the deflection of a certain beam. For example, here, this is a beam, W, this is R1, and this is R2. Okay, you have here the distance L. Okay, now we are going to formulate an equation with respect to X, or in a function of X. If I'm going to cut this section, okay, and if you remember, our orientation as positive is this one, you have here as your M, okay? This is your positive moment. If you consider this side, this is your positive moment. If you consider this side, this is your positive moment. And this one also your positive shear, okay? Now, if I'm going to get the moment of this one, let's say I will consider this side. So I will have this beam, okay? This is my beam. This is my R1, okay? And then you have here the uniform load, W. And then you have here the distance, which is equivalent to X, okay? This is the distance which is equivalent to X. And this is now your moment. Now to apply this double integration method, you just have to get what is the moment with respect to X. What is this M? So I'm referring to M, this one is located here at a certain value of a distance X. So going here, so we just equate, all going here is positive, but this one is, you could equate like this, okay? Counterclockwise direction is equal to clockwise direction. So M, this is M as clockwise, as positive. So this is M. So this one, if I take moment for R1 going here, is also positive. So you have here R1 times X, okay? And then W, the resultant here, it's going over here, that becomes negative because our positive here is going in the clockwise. W times X is already counterclockwise. That becomes WX, okay? WX. And then distance from here, okay, is X over 2, okay? So you have X over 2. Okay, so this one will be your value of your second derivative. When you integrate this one, if you integrate this one, you need to remember this formula. Okay, if you have, when you integrate, just recall this formula, X is equal to N. How are you going to integrate this one? This is X. Of course, we have dx here, okay? This become X, N plus 1 over N plus 1 plus C. There is constant C if that is indefinite integral. This is indefinite integral because there is no limits here. Okay? Wala siyang limit. Kung may limit siya, may specific na value. Ibig sabihin, wala na siyang arbitrary constant. Okay? So, if you are going to integrate this one, you will become the first derivative. That becomes the slope. R1 is constant. So you have just R1 x. Anong power niya? 1 plus 1 and plus 1 will become squared over 2. And then you have minus W. Actually, this one is WX squared over 2, right? WX squared. Okay. This is 2. X squared over 2. X squared. So x to the power of 2 plus 1. 3 over 3. Okay. Plus C1. Okay. Now, if you want to get the formula, we're actually getting the equation. Equation of here, the moment, equation of the slope. Then here is the equation of the deflection. Once you have the equation of the deflection, then you can determine the deflection, specific deflection at a specific distance along the beam. Okay, so you have your deflection. Integrate again. R1 will become R1. X cubed will become 2 plus 1 will become 3. And here you have 2. Magiging 3 ito. Okay? Minus WX cube. Okay? Ito magiging 2 times 3, 6. Hindi pala na to cube kasi 3 plus 1. Okay? 3 plus 1 become 4. Ito magiging 4 din ito. Okay? Plus, sa integral calculus, when you integrate a constant, you just have to multiply by x. So ito magiging C1 x and then another constant. Okay? So you have the equation for the moment, equation for the slope, and then equation for the deflection. So after this, you can compute now what would be the value of your moment or the value of the deflection. Okay? So let's start this one. Okay? Let's try to calculate this problem. Okay, wait. So you have compute the midspan deflection. So this is 4. Hindi ko na ipakita dito. This is 1. 1, ayan. 4. So total is equivalent to 6. So better to calculate first the reaction. So RA, ito naman RB. Okay? Compute RA and compute RB. Ito yung maging resultant dito, di ba? 200 times resultant load. I should say for this load. Okay? From here to here. Times 4. Okay? That becomes 2 times 4 is 800. Okay? So if we take moment at B, okay, take moment at B equals to 0. Dito tayo mag-ikot. Clockwise is equal to counterclockwise. Ano yung mga clockwise forces? RA first. RA times 6. Okay? And then, the rest, counterclockwise na. Itong 100, anong distance mula dito hanggang dito? You have 5 meters. So you have equals to 100 times 5 meters. Okay. How about this 800? Distance here, going here. See, you have 4 meters. So this becomes 2 meters. So you have plus 800 times 2. So what is the value of RA? Or RA. Can you calculate? 500. Okay. 500 plus
350, sir.
Okay, very good. 350. Okay, 350 kilonewton. So ito yan, RA or R1 sa 350. Ano siya? Okay. 350 kilonewton. We need this 350 specifically now to compute the moment. Okay? Okay. Yan naman calculation ko pala una. Ito yung moment na kailangan natin. Ano yung M na yan? Okay? So, 350 times, ayan o, 350 times X. Ito yan, 350 times X. Ito naman 100. Ito, kung X ito is 1. Yan, ito naman, no? So, this one is X minus 1. Kaya, papunta dito, negative siya kasi ang orientation natin papunta doon, positive kasi nga equated na siya sa M. Ano? Okay, M to is equal. Ito papunta dito. So, positive na rin yung mga papunta dito. Kaya ito na yung M. Ito yung M, okay? 350x, 100 maging negative, times x minus 1. Ito remaining dito, ito 200. Itong distance from here, kasi ito 1, ito, okay, mula dito hanggang dito, ito 1, ito 1 maging 2. So ito, this is x minus 2, okay? So minus 200, ito yung 200, ayan na, no? 200 times x minus 2, ito resultant load pa lang to. Kalahati niyan, or half that one is the moment arm. Okay? This one is x minus 2 over 2. Ito na yan. Okay? So we simplify, this becomes 350x, 100 minus x minus 1, minus 200 divided 2 is 100, x minus 2 is squared. We integrate again this one, this becomes 350. Ito maging squared over 2. Ito naman, x minus 1 is squared over 2, maging 100 din. O, copy lang. Ito 100 copy, x minus 2 to the power of 2, magiging 3 kasi plus 1. Tapos, kung 3 dito, 3 na rin dito, plus C1. Arbitrary constant. Integrate ulit para ito, take note, this one is slope. Ito moment, ito na is deflection. Deflection. Okay? Okay. So you have 350 over 2. X magiging cube. 3 times 2 magiging 6. 100 x minus 1 yung 2 maging 3 times 2 maging 6. Minus 100 x minus 2, 3 maging 4 times 3 maging 12. C1 maging C1x and then C2. Once you have this equation, you have to understand now how you're going to first calculate what are these constants. Okay? Ayan yun, okay? You have to understand what are these constants. Okay. Wait. Okay? So, kung ito yung beam, ano? Ganun siya eh. Paano mo ma-figure out when x is equal to 0, y is equal to 0? Itong y, take note, is deflection. Pagka ito yung, ano, this one is the, elastic beam. If this is the Cartesian coordinate system, this is y-axis, this is x-axis. Ito yung 0. Kung yung x daw 0, ito naman dito, ang distance nito is, what's this distance? 6. Okay. Here, ang distance niya is 6. So, the coordinate here is 6 and 0. Kasi nga, ito, 0, ito, origin 0. Ito, positive, negative, positive, negative. Papunta doon is 6. Pero ang y-axis, ang y niya dito is 0 pa rin. So, when x is 0, okay, kung x is 0, andito yung x is 0 and y is 0. Kung x is 0, yung y is 0 pa rin kasi yung y na sinasabi yung deflection. Kasi may support naman siya, kaya yung y niya dito is 0 pa rin. Walang deflection kasi may support dito. For sure, mayroon dito y kasi ito na yung deflection, wala man support. Magde-deflect man siya pagka walang support. Okay? So here, we can say that when x is 0, y is equal to 0. Take note that when you substitute here, saan ka mag-substitute? This one is moment, y double prime. This one is y prime. Ito y, ito, dito ka mag-substitute. So, when you substitute x is 0, ito, yan, 0. X, 0 minus 1 is negative 1. Pero the rule is, Pagka maging negative, 0 na rin siya, kaya 0 siya. X minus 2 maging 0 na rin. Ito 0. Ibig sabihin, C2 na lang yung matitira, C2 is equal to 0. Okay? C2 is equal to 0. Now, when X is equal to 6, pagka nandito na tayo, X is 6, Y 0. Saan tayo mag-substitute? Dito pa rin kasi ito ang ginamit natin. Okay? Paano Y prime 0? Pagka Y prime yung 0, ibig sabihin, slope is 0. Asan yung slope niya? Ano? When the maximum, at the maximum value of Y prime, at the Y prime, okay? Pagka first kuwang ka, nasa first derivative, okay, you will get a maximum value of slope which is equal to 0. Okay? Ibig sabihin, makakompute mo dito Y prime, maximum. Okay? Slope is 0. It's horizontal line. So dito, ang sinasabi ko dito is, when X is 6, Y is 0. Kasi pagka sa support, walang deflection. The purpose of which is to compute natin yung C1. Dito, na-compute natin, dito C2. Now, move tayo doon, kasi may value na tayo ng C2, move tayo doon, makakompute natin yung C1. Okay? So, X is equal to 6. Ito, mga X yan. And then, yung Y, 0 pa rin. So, makakompute natin yung C1. Pagka na-compute natin itong C1, i-substitute natin dito, makakompute na natin ang deflection. Anong tinatanong? Mid-span deflection. If this is 6, the mid-span is when X is equal to 3. Okay? Okay. Okay. Pagka sinubstitute na natin, okay, substitute natin yung X is equal to 3, makakompute na natin yung Y. Makakompute natin tong EIY. Okay? This one is the property, modulus rigidity, property of a material. Okay? Depende kung what kind of material you have. Concrete beam, you have concrete modulus of elasticity for concrete, and then I for that type of section, BD cube over 12. Pagka steel, yung E, modulus of elasticity is 200 gigapascal. So, madali na makompute yung Y. Yan na yung deflection. Okay, so we just substitute. Ito, AIY, substitute yung E at saka I, given na to. If not, pagka steel, halimbawa, modulus of elasticity of steel, this is 200 gigapascal. And then yung I naman, nasa table naman. In case, yun na yung magko-compute kayo, may transfer moment of inertia. Ano? So, in this problem, given na yung E over I. Okay? Usually sa mga problem na deflection problem, given na yung E over I. Substitute nyo na lang. Okay? And what you need to remember here is the unit. Okay? And the unit. Okay? So, pagka pagka sa slope, EIY, slope equation, Newton millimeter cube. Cube siya, ang distance. Pagka sa, this one sa deflection, sa Y to the power of 3. Pagka sa slope, ang millimeter doon or ang distance to the power of 2. Pagka sa double Y prime, Y double prime, isa lang. Okay? Kasi moment yan Newton meter yan. Okay? Yun ang dapat na tatandaan nyo. Okay, so we can compute here. Ito negative, ibig sabihin pababa kasi deflection. Okay? Yung beam, ito yung beam, nag-deflect pababa. Kasi nga, we are talking about equation. Ito yung 0, ito yung 0. Going up is positive. Okay, going up is positive. Going down is negative. Ito yung y natin na kinumpute sa gitna na negative. Negative 275.83. Ibig sabihin, deflection siya, pababa siya. Okay? You can write it in this way. Pero sabi mo, deflect, wala man may mga cases na deflect pataas, depende sa forces, okay? So mostly sa mga suspended type of structure, ang deflection is pababa naman. Okay, so I think that's all for today.